So as we move into 15.2, solving quadratic equations, we're going to look at solving quadratic equations by factoring this time. So we talked about a pure quadratic. Now we're going to look at some other types of quadratics. So one of the things we have going on here is what's called the zero product property. One of the things we should know that we know that when you multiply by zero, the answer's got to be a zero. So when we say the word factors, remember factors are things that are connected by multiplication. So if I have like two things connected by multiplication to equal zero, if I say, what can you multiply? If I pick, let's make this a little more concrete for you. Let's just say I pick a 5. 5 times what value would give you 0? Notice that this other factor would have to be 0. There's no other number you can multiply 5 by to get 0. That's what's called the zero product property. If you're multiplying to get 0, one of those factors has to be 0. So if I say something times something is equal to 0, if I say this is 0, then it really doesn't really matter what the second number is. But if I say it's a 5, notice that I would still get 0. So this is what this property is trying to say. A times B represent the factors of a polynomial. The only way to get equal 0 is each one of those factors must be equal to 0. So A and B must be equal to 0. So where this is applied at is when we start to factor quadratic equations. So the first example we're looking at is to solve an incomplete quadratic equation. An incomplete quadratic equation, the quadratic term and the linear term are present, the constant's missing. So the first thing we want to do is make sure the quadratic equation is in standard form. So if it's not, we want to apply the strategies to put that in standard form, which they call the addition axiom. In other words, we call that the property of equality. So then we want to factor out all the common factors and set each factor containing a variable equal to 0 using the zero product property. So then we want to solve each variable of each equation that we created in step 2. And it's always a good idea to check to see if your answers actually work. So check your solution to the original equation. So if I look at this first example, I have this 2x squared equals 5x. So the first thing that has to be done is when you're looking at this, since this is not a pure quadratic, what we want to do is we want to set the equation equal to 0. So we write this as 2x squared minus 5x is equal to 0. And now it's actually what's called an incomplete quadratic. So an incomplete quadratic, we're looking for the greatest common factor of the two terms. So again, we're talking about the 2x squared and the negative 5x. We're asking ourselves, what are its factors? So in my mind, what I'm looking at is there's a 2, there's an x, and there's an x, and we have a 5 and an x. So as far as common factors go, there is an x in common, and that would be it. So when it comes to factoring 2x squared minus 5x, the common factor comes out in front, and the remaining factors stay inside there. So this 2x will stay inside, and the 5 will stay inside. So 2x minus 5 goes back together inside there. So that's not what we call factor form. So what we do now is we set each factor that's got a variable in it equal to 0. So both factors have a variable in them. So what we do is we set x equal to 0, and we set 2x minus 5 equal to 0, and we then just solve each one of those equations for x. Well, the first one's already solved for x equals 0, but the second one we have to add 5 to both sides. And this gives us then 2x is equal to 5. And then we have to divide both sides by a 2 to get the x by itself. And that would give us then x equals 5/2. So that would be the two solutions. So 0 and 5/2 would be the two solutions. Now, if I want to, I can check them in the original equation. So if you have 2x squared equals 5x, if I put 0 in, this is 2 times 0 squared equals 5 times 0. Well, that's going to be 2 times 0, which is 0, and 5 times 0 is 0. So since it's a true statement, that means 0 is a solution. The other one I could put in is the 5/2. So this is going to be 2 times 5/2 squared equals 5 times 5/2. So this becomes 2 times 25 fourths. 25 fourths. That's 5 squared is 25 and 2 squared is 4. Notice how the 2 and the 4 will cancel there. You have a 2 on the bottom. So this is 25 halves on the left side. And the right-hand side, you can't make that 5 over 1. That's 25 over 2. That's 25 over 2. So we do have 25 halves equal to 25 halves. So it does check out. So 0 and 5 halves were solutions. Let me go ahead and erase this. I may need the space here. So our next equation that we have is going to be the 4x squared minus the 8x. Where'd you go? So B, we have 4x squared minus this 8x. And that's equal to 0. So we do have a quadratic equation. It's equal to 0, and it's already in standard form. Since this is an incomplete quadratic, we just have the quadratic term and linear term. The strategy is actually looking for the GCF. So mentally, what you should see is, 4x squared has 2 times a 2 times an x times an x in it. And that 8x has a 2 times 2 times a 2 times an x in it. So what I'm trying to do is identify the common factors. So notice how they do have an x in common. And they do have actually 2 2's in common. So what we do is we pull that all out, but what we do is we put that all back together. So that means 4 and an x come out. So 2 times 2 is 4, and the x comes out. So 4x actually comes out. And then what's left is just that x and a minus 2. So x minus 2 would be remaining inside the parentheses. The remaining factors stay there. Again, you can always multiply this back out. This should get you back to the original problem. So 4x times x does give you 4x squared, and 4x times negative 2 does give you negative 8x. So that does check out. So remember, there's what's called expanded form, and there's what's called factored form. We want it in the factored form. So now instead it's factored, we set each variable factor equal to 0. Well, since both factors have that, we just set 4x equal to 0, and we set x minus 2 equal to 0. So we set those equal. And notice how we can divide each side by 4 here. And that's just going to give me x equals 0. And we can add 2 to both sides if we want to, or just move the 2 over to the other side of the equation. And we have x equals 2. So that would be our 2 solutions, 0 and 2 would work. So the next type of quadratic equation that we're going to solve by factoring is called the complete quadratic equation. That means all 3 quadratic pieces are present. The quadratic term, the linear term, and the constant are all present. So if we have a complete quadratic equation, we want to arrange each equation in standard form. So we want to make sure one side is equal to 0, and the quadratic term, the linear term, and the constant are on the other side of the equation. From there, what we want to do is factor the trinomial into 2 product of binomials. So we want to factor it into 2 binomials. And then we want to set each binomial factor equal to 0 and then we're going to apply the 0 product property. So we're going to then solve each one of those little equations that we found in step 2. And then we want to check if desired. So if I look at this first example, we have x squared plus 6x plus 5 is equal to 0. Notice how that is in standard form. So remember, if it's a trinomial, what we're first looking for is a special product. Is it a perfect square trinomial? Well, the first term is a perfect square, but you can't square a number and get 5. There's no whole number squared that gives me a 5. So this is not going to be a perfect square trinomial. So this is an example of a general trinomial. With general trinomials, I usually just use the box as an organizer. There's many ways to do this. So in using the box method, what we do is we place the quadratic inside the box. So the quadratic term goes in the top left. the constant, the 5, goes in the bottom right. Now, since the coefficient of x squared is 1, when you multiply 1 times 5, you still just get 5. So when we make our big T, what we're doing is we're looking for the factors of the constant, which is a 5, but they have to add to give me the middle term, which is a 6. So I need to get that 6, that linear coefficient. There's only one pair of factors for 5, and that's 1 times 5. Notice that 1 times 5 does give me 5, and 1 plus 5 does give me 6. So it does pass both of these tests. If it doesn't, then we cannot factor it. It would be called prime. So what do we do with this 1 and 5? They become the new coefficients of our linear term. So what we do is we put the 1x here and the 5x here. So that's how what we did is this x squared plus 6x plus 5, we placed it inside the box, but notice how the linear term is unpacked into 2 separate pieces. So we have x squared plus 6x plus 5. What this allows us to do now, though, is use factoring strategies. So what we do is we look across the first row, this x squared plus 1x, and we identify the greatest common factor, kind of like we just did. So notice how there is an x in common. So then we just kind of piece this all together. You know, what times x gives me x squared? That would have to be an x. And then we go up to this next spot up here. What times x is 1x? Well, I need a 1 there. 1 times x is 1x. Then I move down here to the bottom row, and I'm looking for this piece. So what times x is 5x? I need a 5. And then does 5 times 1 give me 5? Yeah, it does. So that creates it. So the outer edges becomes our factorization. So this becomes our binomials. X plus 5 times this x plus 1 is equal to 0. It doesn't matter who you write first. If you wrote down x plus 1 times x plus 5, it's still correct. Now that we have it factored into 2 binomials, we set each binomial equal to 0. And we're going to be applying the zero product property there to that. So we end up with x equals this -5. We end up with x equals this -1. So that'd be our 2 solutions, -1, -5. That'd be our 2 zeros. And again, if we want, we can check those as needed. So if we look at this next example, we have this 6x squared plus 4 equals 11x. Notice that equation is not in standard form. So notice how this 11x has to come over to this side of the equation. In doing so, notice how it has to change sign. So I like to put it in the correct order. So 6x squared minus 11x, the linear term would go next, plus the 4 would equal 0. So again, we want to factor this trinomial, but since it's not a perfect square trinomial, because there's nothing squared that gives me this 6x squared, and there's nothing squared that gives me this 4 either. So this crashes rather early. It's not a perfect square trinomial. So what we can do, though, is use the box as a factoring strategy. So what we do is we place the quadratic term in the top left, the constant in the bottom right. Now notice how this time, though, the quadratic term has a coefficient. We got to actually multiply the 6 times the 4 together. So 6 times 4 gives us this 24. So we actually got to use the 24 as our factors, our big T. And the catch is we still got to get this -11 as our linear coefficient. So the -11 has to also appear in this math over here. So we list our factors of 24, 1n, 24, 2 times 12, 3 times 8, 4 times 6. 5 doesn't work, and 6 times 4, that's just repeating now. So I'm looking for one of those factor pairs that's going to give me the -11 as well. So it looks like this 3 and 8 is my best choice. But notice how they both have to be negative. That's be a -3 and a -8. So notice how -3 times -8 does give me a positive 24, and -3 plus -8 does give me this -11. So I've achieved what I needed. So this allows me to build the rest of the box. So this -3x goes here, and this -x goes here. And again, it doesn't matter what spot you put those in. So our next move is we want to identify the GCF of the top row, the 6x squared and the negative 3x. So notice that they do have a 3 and an x in common. So 3x comes out. So from here, I basically just start just putting it all together. What times 3x gives me 6x squared would be 2x. 2x times 3x does give me 6x squared. And 3x times what gives me this negative 1. What goes up here times 3 that gives me this, times 3x that gives me this negative 3x would be, I need a negative 1. So negative 1 times 3x does give me negative 3x. So I now move to the bottom row, and I still need this outside piece. What times 2x gives me this negative 8x? I'm going to need a negative 4 there. Negative 4 times 2x does give me negative 8x. And then finally, does negative 4 times negative 1 give you this positive 4? And it does. So we've kind of got it. So the outside becomes the factored form. The inside is kind of that expanded form kind of thing. So we're going to bring the outside of the binomials there. So we have now 3x minus 4 as one of them, and 2x minus 1 is the other. So now what we want to do is set each one of those factors equal to 0. So I have this 3x minus 4 is equal to 0. And I have this 2x minus 1 is equal to 0. So we just want to solve each one of those little equations for x. So I add 4 here, I got to add a 4 over there. So we end up within this 3x equals 4. Then I got to divide both sides by a 3. So x is going to equal then this 4/3. Over here, you have to add a 1 to both sides. So we end up with then 2x is equal to 1. I got to divide both sides by 2, so x equals 1/2. So that would be my two solutions, 4/3 and 1/2. Again, if I check those, I substitute them back into the original equation, the 6x squared plus 4 equals 11x, it should give me a true statement. Alrighty, so that's some good examples of how to solve quadratic equations using factoring.